Okay, before we start deciding how to label what types of chemical reactions there are, let's talk about what makes a chemical reaction a chemical reaction. So, a long time ago in August, we talked about how to describe chemical changes, and so we talked about that there are 4 easily observed changes that we can see that identifies that a chemical reaction has occurred. So if you remember them, number 1 is if you see light or heat, and it could be an added heat or an absence of heat, meaning it gets cold or hot. That is a sign of a chemical change. To production of a gas, you can usually see this if you see bubbles of some kind. The formation of a precipitate. It's been a long time since we heard this word, precipitate, which is when you get a solid when you mix 2 liquids together. It looks like some cloudy chunks. That's what a precipitate looks like. It's not going to be a rock solid stuff, but it looks cloudy, ugly cloudy chunks. Remember the Red Bull and milk that we mix together. And then if you see an unexpected change in color. Okay, so we're not talking about expected changes, we're talking about unexpected changes. So a chemical equation can be written, okay, properly if the following 3 requirements are met, okay? You need to make sure that all equations have all the correct elements and or formulas. They have to be written correctly. So later on when you guys write out your formulas, you guys have to make sure that they are correct. Okay? So formulas such as diatomics are really, really important, right? That they are written correctly. So here we have Brinkelhoff. Brinkelhoff are 7 elements, okay, 7 of them that always come in a pair. So always remember Brinkelhoff. Say it out loud to yourself. Brinkelhoff. Brinkelhoff. Tell a neighbor. Brinkelhoff. Brinkelhoff is bromine, iodine, nitrogen, chlorine, hydrogen, oxygen, and fluorine always come in pairs. You never see them by themselves, okay? Now remember the law of conservation of mass. Now, what does law of conservation mass say? That elements, basically all of matter, cannot be created nor destroyed. So this all goes back to when we balanced our equations, that whatever you start with has to be whatever you end with. Okay? Now, another fact of chemical equations is that any reaction that is not double replacement, and we'll explain what this word is called an oxidation-reduction reaction. Sounds very complicated. It's very simple. Basically, a redox, which is reduction and red in reduction and ox in oxidation. So redox is when you have electrons that are transferred from one atom or element to another. Okay? For this to happen, one must lose electrons because the same electrons are then going to be gained by another element. Okay? So, if electrons are being lost, that means that it has to be getting transferred to someone else. So, this transfer of electrons, okay, happens in most type of chemical reactions, okay, except double replacement. So we'll explain what double replacement looks like, okay, and we call them redox for short, red for reduction, ox for oxidation, okay. So let's talk about your 5 different types of chemical reactions. The first type is called a synthesis reaction. Synthesis. To synthesize something is to bring something together. Okay, to bring it all together. So here are some examples. Okay, if you take an element and an element, right? Element and element, you get one big compound. You can take a compound and a compound and make an even bigger compound. Or you can take an element and a compound and still make one compound. The point is you're always left with one product. There's only one big thing after the arrow. One big thing after the arrow. One big thing after the arrow. That's how you know it's synthesis. Synthesis is considered a redox reaction, meaning electrons do get transferred. Okay, the second type of chemical reaction there is called decomposition. So we've used the word decomposition before. You should know what it means. It means to break down. So it's the exact opposite of the synthesis reaction, meaning you start off with one really big thing and it breaks apart, right? One really big thing and it breaks apart. One really big thing breaks apart. Okay, so it's the exact opposite of synthesis. Synthesize means that you are going to bring it all together. Decomposition, means you're going to break it down. Okay? Decomposition is also a redox reaction, meaning that there are transfer of electrons. Okay, the next type of chemical reaction we have is called a single replacement. The word single should really help you out here. Okay, so if you look at this example here, A is all by itself and BC was a couple. Then on the other side of the arrow, AC is now a couple and B is now all by itself, aka single, right? So look at these pictures over here. Here they are together and she's single. Now they are together over here, and now she is single. So there's always a third wheel, someone being left out. So if you look here at the actual chemical example, lithium is by itself, sodium and chlorine were a couple. Now lithium and chlorine hooked up, right, over here, and now sodium is now the third wheel. Okay, so over here, selenium was the third wheel, calcium and sulfur was a couple, now calcium and selenium became a couple, and now sulfur is the third wheel. So that is called a single replacement. So always think about the word single. Okay, the next type is called double replacement. This one is usually easy to spot. It's when you have a couple with another couple and you switch partners. I like to say you're switching dancing partners, right? Here you have a penguin in a hat, pig in glasses. On the other side, you have a penguin with glasses, pig in a hat. So they basically are swapping partners. Okay, so if you look here, red circle, blue square, yellow circle, green square is now going to change partners. Yellow circle with blue square, red circle with green square. So you have to have a total of 4 things, 4 elements or polyatomics, right? So here's lithium and fluorine, sodium and chlorine, and now they're going to switch partners. Lithium is now going to go with chlorine, and sodium is now going to go with fluorine. So they're all about switching partners. Calcium is with sulfate, magnesium is with carbonate, and if you look, calcium is now going to hook up with carbonate, magnesium is now going to hook up with sulfate. So remember the difference. Single replacement means that someone's always got to be by themselves, but in double replacement, you're just swapping partners, okay? The very last type of equation or a chemical reaction you can have is called combustion. Combustion reactions are pretty cool. Okay, you combine the substance with oxygen and it always creates the same products, water and carbon dioxide. This is going to come really handy, this little sentence right here. The products are always water and carbon dioxide. So here's water, here's carbon dioxide. Here's water, here's carbon dioxide. Basically, your combustion reactions are always CHO equations. Always CHO. If you have a CHO, you have a combustion reaction. Okay, so there's not a cute picture that goes along with it, but CHO equations are combustions. So earlier you did this practice, and hopefully you got all the answers already. But I'm just going to do a few examples with you, and then you guys can do the rest. So here is number 1. So you take a look. You're like, all right, iron is all by itself. Hydrogen is hooked up with sulfate. Iron is now hooked up with sulfate, and now hydrogen is all by itself. What type of equation could this be? Well, it can't be synthesis because it doesn't have just one product. It's not decomposition because we're not breaking anything down. But it does look like single replacement. Why? Because you have a single element here and a pair here. You have a pair here, single here. So the type is single replacement. Is it redox? Yes. Every single type is redox except double replacement. Okay? Even combustions have a transfer of electrons, but not double replacement. So here's number 2. Number 2, here's water, here's carbon dioxide. This is a CHO equation. This must mean that this is combustion. Combustions are also redox because it has a transfer of electrons. Okay, let me do one more. Here's K, here's chlorine, and now I have one big thing. So which type out of the 5 takes small things to make only one big thing? Right, it's synthesis. It comes together as one product. Synthesis is always redox as well. Everything should be yes except double replacement. Double replacement is the only one that is not redox. So you should be doing the rest of this page and getting more practice on this, and there is another extra practice page for whenever you are ready.